In this video, I'm going to show you how to solve a very simple problem in two different frames of reference, and you can decide which one you like more. So what we have here is a river flowing to the right at 5 meters per second. And there is a raft in brown. This raft drifts down the river, so it's moving at the same speed as the river, 5 meters per second, and moving to the right along with the river. We also have a boat here, and this boat is capable of going at 12 meters per second in still water. I'll call that velocity V prime. That's the velocity of the boat in still water. So if the boat is moving downriver, that is in the same direction as the flow of the river, you can understand that the boat is now moving at 17 meters per second. And let's say the boat crosses the raft at time t equal to 0. And what the boat does is it moves for 20 seconds downriver after it crosses the raft. At the end of 20 seconds, it turns around and starts moving back. Of course, when it's moving back, remember its velocity is going to be 12 minus 5, so 7 meters per second to the left. But in the meantime, the raft has been drifting to the right, so at a certain time, the raft and the boat cross each other once again. Question is, how far does the raft drift during this time from the moment when the boat crosses it first to the moment when it crosses it again? That is the question. So let's start with solving the problem in the ground frame of reference. That means somebody standing on the shore. That person will see the boat moving at 17 meters per second for 20 seconds. That's the time it moves before it turns around. So during this 20 seconds, it's going to cover 340 meters. So this distance, the pink line, is 340 meters long. Let us say that after it turns around, it takes t seconds for it to meet the raft again. Now the raft has been moving, remember, for 20 seconds while the boat is going up, and for t seconds when the boat is moving in the direction opposite to the river. So the raft has been moving for a total of 20 plus t seconds. So the distance moved by the raft, which we need to find out, is speed of the raft, which is 5, multiplied by 20 plus t. This is what we are trying to find. So all we need to do is find t. Well, if you look at this drawing, the answer jumps out at us. What is this distance that the raft has moved? That is 5 multiplied by 20 plus t. Let me expand that. That is 100 plus 5t. Plus, what is the distance that the boat has moved on its way back? Remember, on its way back, it's now moving at 12 minus 5, 7 meters per second for t seconds. So that's the distance that the boat has moved. Together, the sum of the two distances is equal to 340 meters. Now pause for 1 second and take a good look at this. You might well have understood this equation, but what is more important is to see how we managed to easily get the answer. The equation jumped out at us from the drawing. You can see that this is 340 meters, that is 7 times t, and that is 5 times 20 plus t. So this distance plus that distance is 340 meters. The answer jumps out from the drawing. This is extremely important. I keep emphasizing this. In every physics problem, please draw a diagram. Right? So we have 5 plus 7, 12t. Let me take 100 that side. That makes it 240, and that gives me t is equal to 20 seconds. In other words, the boat takes 20 seconds more going upriver before it meets the raft. So take 20 seconds and plug it in here. We get 5 times 40, that is equal to 200 meters as the distance that the raft has moved. Now let us do the problem from a different frame of reference. What we are now going to do is solve the problem in the raft frame of reference. Now try to visualize this. You're sitting on the raft, you are drifting down river. Now what do you see? You see that the raft is not moving. The river is not moving because the river is moving with you as seen from the ground. So with respect to you, the river is not moving. So you are in still water. As far as you are concerned, you are on a lake. And you look around and see that the trees and the shoreline moves backwards at 5 meters per second to the left. What do you care? You are in a peaceful lake. Nothing is moving. The shore, the trees, the monkeys on the trees, all of that is moving to the left at 5 meters per second. That is not our concern. What is our concern is, here is a boat that comes along. Now, in your frame of reference, the river is not moving, so it's a lake. So the boat's velocity in still water is 12 meters per second. So here is a boat that crosses you at time t equal to 0, moves for 20 seconds. And as far as you're concerned, remember, you are stationary. So the boat moves for 20 seconds, turns around and comes back and meets you. So how long do you think it'll take to come back to meet you? 20 seconds. It moves forward for 20 seconds. You're on a lake. It comes back in 20 seconds. Totally the boat has been moving for 40 seconds. Now jump to the ground frame. In the ground frame, what do you see? Now we know that it takes 40 seconds for the boat to meet the raft again. In 40 seconds, the raft would have moved 40 multiplied by 5, that is 200 meters. That's it. That's how we solve the problem in the moving frame of reference. Now pick your frame, but the important lesson here is some problems are easier to solve in one frame than in another. Thank you.